So this is the Skill 8 video, which is working with inverse trigonometric functions. So basically we had to do A, B, C, and D to cosine inverse and secant inverse, and then we had to compare and contrast the domains and ranges and how to algebraically show these values. So here I have, well, first for A, B, C, and D, I chose 6, 4, 5, and 4. Now, so here's the parent function for the inverse cosine. So as you can see, the domain is from -1 to 1, and this has brackets around it, and then the range is from 0 to pi. So now here is the new translated or transformed cosine inverse function, and the domain for this is 4.75 to 5.25, and the range is -π/4 to 23π/4. So now first, for calculating the range, you have to take into consideration the A and the D value. So what you have to do is you have to plug in 0, and then you also have to plug in pi. So what I did is that I did 6 pi minus π/4, and then 6 times 0 minus π/4. And this is again obtained from the A and the D value. And so then I basically just solved, and I got -π/4 and 23π/4, and that corresponded with the range that I got on Desmos. And now for the domain, it's the B and the C values that affect it. So what you do is, since the range is going to be between -1 and 1, I basically wrote -1 is less than or equal to cosine of x, which is less than or equal to 1. So then I set this 4x minus 20, now it's minus 20 because it's 5 times 4, so I set this 4x minus 20 equal to -1, and I set it equal to 1. And then I just solved for x, and for x I got 4.75 for one of them, and then I got 5.25 for one of them. Now you could also find the domain by setting it equal to 0, but this is the method I chose. And this corresponded to the domain I got from Desmos. So as you can see, like in simple terms, I guess, the A and the D values affect the range, and basically you make this entire thing x, which is in the middle, and you substitute these two values for the range, and then for the domain, the B and the C values affect it. And then here I have like more detailed explanations on why that is, but you can just see that in the written. Now moving on to the parent function for secant inverse, or inverse secant. So this is essentially what it looks like. So the range is going to be from -∞ to -1 bracket, union with 1 to +∞. And then the range is going to be from 0 to π/2, because this line, oh, this is such a bad line, because there's like this horizontal line here, which is π/2. And then it's going to be union with π/2 to pi. And so I again did A, B, C, and D to it. So this is now the new transformed or translated inverse secant graph. And so the domain was -π to 4.75, union with 5.25 to infinity. So basically, the cosine graph, it's basically, if you see like the similarities and the differences here, this is very similar to here. However, this accounts for like the gaps, I guess, in the graph. And that's like the main difference, because as you can see, like the 4.75 and the 5.25 is the same values here, and it's like the same method that you use. So again, you're going to put in -1, you're going to like set 4x minus 20 equal to -1 equals to +1 again. However, you have to take into consideration the -∞ to that point, union with that point to +∞. Now the range is slightly different. As you see, this -π/4 value and this 23π/4 value is the same as the range above, because you still have 0 and pi as part of your range. However, you do have the vertical asymptote that you're solving for, and that is 11π/4. Now you solve that by, again, doing the same thing, 6 in parentheses π/2 minus π/4. Now the 6 and this minus π/4 came from the A and the D value, and this π/2 is new, and it comes from like solving for the vertical asymptote, or I mean horizontal asymptote, lol. Wait, no, yeah, it is vertical asymptote. And this is how you do Skill 8.